Welcome to lecture 16, 8051 timer programming using embedded C. In this lecture, we are going to discuss timer 1 mode 2. Timer 1 mode 2 means 8-bit timer auto reload mode. Already in the previous lecture, we discussed mode 0, mode 1. In this lecture, I am going to discuss mode 2. It is a 8-bit timer auto reload mode. We will see what is auto reload mode. This is a program. Write an 8051C program to toggle only pin P1.5 continuously every 0.25 millisecond. Use timer 1 mode 2. It is a 8-bit auto reload to create the delay. Here oscillator frequency I given as 12 MHz. So far in the previous lecture we discussed the oscillator frequency as 11.059 MHz. In this lecture I using for change I am using 12 MHz as a crystal frequency. So this is a 8051 microcontroller. Here it is a P1.5. For every 2.5 millisecond the LED is going to be toggle in the sense on off. Every 0.25 seconds my LED is going to be on off. 0.25 millisecond it is going to be on, 0.25 millisecond it is going to be off. Toggle this one, the next toggle it is 0, the next toggle it is 1 0 1 0, so on. So this is we are going to be uptime in this program. Just carefully listen. There is a small difference between mode 0 and mode 1 program. Here they include REG51H as usual, S bit, my bit, P1 cap 5. The P1 cap 5 is assigned with my bit. Here I am using the user defined function void timer 1 mode 2. It is a delay function. So for understanding I am using the delay function as T1M2 delay. As your wish, there is a programmer choice, you can keep any user defined function name. Void main void. So tmod, here it is a tmod register to configure which mode I am going to be operate my 8051 timer. So here timer 1 mode 2, it is 8-bit auto reload. I will tell what is 8-bit auto reload. First, how to configure timer 1 mode 2. Just come over here. This is a tmod register. It is a 8-bit register. This lower byte it is related to timer 0. Higher byte it is related to timer 1. So I want timer 1 mode 2. So you can keep M1 as 1. So this become auto reload, that is mode 2. So you can convert this 8-bit the binary into hexadecimal. You will get 20H. So here I written as 0x20, or else you can, in place of 0x, just you can write 20H also, it is correct. Okay, 0x20 is nothing but it is hexadecimal, so 20H. Now I want to calculate the time delay of 0.25 millisecond. After that I come over here. This is the time delay I calculated. I loaded in TH1. I am not going to use TL1 register over here. That is the beauty of 8-bit auto reload mode. Okay, fine. Here the finding values to be loaded in the timer in the red color mark, because I am using in this lecture I am using the crystal oscillator frequency as 12 MHz. So the 12 MHz divided by 12, you will get 1 microsecond. That is a desired time delay for this program. So each and every event the register is incremented by 1 microsecond. Every 1 microsecond your TL0 register is going to be increment. Okay, fine. Now because of this is a 8-bit timer, so the maximum the value I will get 255 minus n I have to be calculate, plus 1 is equal to n. So how to calculate n we will see. So here I am using 0.25, it is my time, 0.25 millisecond divided by, it is a 12 megahertz frequency I am using, that's why 1 microsecond. So what is the value you will get? 0.25 millisecond divided by 1 microsecond, you will get 250. Okay, this is the n peak and uptime. So you can replace over here n as 250. You 255 is the maximum value subtracted with 250. For getting overflow from f of 200, we had to be add plus 1. So what is the value we will get? The 250 minus 250 you will get 5. 5 plus 1 you will get 0, 6. So you convert 6, this is a decimal number, converted into hexadecimal also you will getting 0, 6. So this is 0, 6H. This is the hexadecimal value. So I keep this 0, 6 over in this program. So this is the hexadecimal. So I loaded 0x06 is loaded in TH1. Here I am not using TL1, but in case of mode 0, mode 1, I used TL0, TL0 and TH0. Both the register I used. Here it is because of 8-bit auto reload. I am not using TL1. I am not using here. Just you go through the diagram. So here it is a crystal oscillator frequency. It is 12 megahertz divided by 12. You will get 1 microsecond. So every 1 microsecond, this TL1 is going to be increment. What is the value you loaded over here in TH1? It is 0x0x 0x06. So this is automatically loaded with TL1. So TL1 is now it is 06. After every clock, so every machine cycle, it is going to be incremented by 1, that is 07, 08, 09, 08 until FF. Once it will get FF, what will happen? It become TF not get overflow. Once it get overflow, the automatically whatever value in the TH1, it is automatically reload with TL1. As a programmer, okay, as a user, you no need to keep on reload 0x06 in the TH1. Okay, but in mode 0 and mode 1, for every time you can load the values, that is delay values in the TL1 and TH1. But in this case, because of it is auto reload, what once you loaded in the TH1, automatically it will loads into the TL1. Once it will reach the FF, once it will get overflow flag is 1, automatically again this TH1 it is loaded with TL1. Okay, so that's why the once I will initialize over here, that's it. T mod is equal to 0x20 because of timer 1 mode 2. TH1 it is the delay. Why? Because for every 0.25 millisecond my output is going to be toggle. That is a program. So while of 1 it is an infinite loop. My bit is equal to complement of my bit. I used to be write the delay function here, T1 M2 delay. Whenever execute this one, come over here. You have to be run the timer. For all the modes you have to be run the timer. There is no other way. So if you once you run the timer, the TF not, it will check the TF not bit is 1 or not. Until that this line, what is that, the program has to be executing the same line. So once it will reach the 1, it comes out of the loop. Again you have to be TR1 is equal to 0, TF1 is equal to 0. So again come back to here, again complement. But in this case, you no need to load this 0x06 into TH1 because of it is 8-bit auto reload. Once initially in the program you loaded in the TH1, automatically once this TL1 reach the maximum value, again it get overflow. After that TH1 value whatever you loaded in the program, that is automatically reload into the TL1. That is the beauty of this timer 1 mode 2. That's why it is called as auto reload. Okay, you no need to reload again and again for each delay program execution. Once you load in the TH1, automatically it is going to be reload in the TL1. After that, once you can start the timer, whatever the based on the internal system clock through this one, it is going to be start increment this register. What is the register value we initially we initialized here? 06. From there it will start the increment 07, 08 until FF. Once it will reach the maximum value, it get overflow. Again this TH1 value is loaded with 0x. 0x, that is 06. that is the value has to be loaded here. Let's see whether we are getting the proper delay in the output with the help of the Keil software. This is the Keil New Vision. Here I am going for the project, new mission project. Here I am using T1M2. Okay, T1M2 is my project name. Here I am going to be select my the target controller, that is 89C51. Just give OK. Now your project is created. New. Here you have to be write your code. After that you go for save, and the same folder you have to be write with the same name, timer1 m2, it is a mode2.c extension, that is very important. Color gets changed. Now I want to add this program under that target, so add existing file, so t1m2, so t1m2 add, close over here. So it is added under this target. Under the project you have to be select the target. Now I am going for the compilation, so 0 error, 0 warnings. The next I am going for build, it is a rebuild. The next I am going for, before that we have to be ensure that what is the crystal oscillator frequency, or else you will not get the proper output. So this is the crystal oscillator frequency, it is 12 megahertz. So I selected 12 megahertz. Then you can go for debug option. Here you go for the logic analyzer. After that you can get this the output window. Here you go for setup. Here you go for this icon. Just you can type which pin you want to get output, P 1.5, and just give enter and close it. Okay, now you go for run this button. So here 0 to 255, but we want 0 to 1. Okay, 0 1 1 0 0 1 1 0 0 1 1 0. That's why you can keep 1 over here. So I am, so just you have to be zoom this one, so I am giving zoom in. I stop. After that I have to be take the signal information as well as the cursor. I just click that one, you will get the cursor. Now I am going to be check for one pulse how much I have to get. I have to get 0.25 millisecond. Just see the delta value, you are getting 0.261 millisecond. You are some the 0.1 or 0.2% deviation. Okay, anyway we are obtaining. So the total time period is 0.521 millisecond, but the exact time delay it is required is 0.5, but instead of we are getting 0.521 millisecond, there is 0.021 millisecond, there is a deviation. Okay, this is a reasonable delay. Okay, this is about timer 1 mode 2. Okay, thanks for watching.